Okay, hi everyone, and welcome to my channel, Maths Made Easy with Terry in 10 minutes, okay? The last video I talked about partial fraction. I introduced the partial fraction concept and also talked about the 5 rules or steps to take while solving partial fraction. So as usual, please, if you've not watched the previous video, you need to watch it. Make a note of the 5 rules or take a screenshot as we're going through this video to solve examples. I'm going to be using those 5 steps throughout to explain, okay? All right, so let's assume we have a question. Let's say we have 8x minus 28 divided by x squared minus 6x plus 8. And you're told to break this down into partial fraction. The first step I told you was that the degree of the denominator must be higher than that of the numerator. So let us check. What's the degree of the denominator here? 2. What about the numerator? Is 1. So that means the degree of the denominator is higher than that of the numerator. So good. We'll move to step 2 now. All right. Now, in step 2, we are told to then factorize the denominator into prime factors, right? So let us factorize x squared plus 2. So the step 2 is that we're factorizing x squared minus 6x plus 8. And I believe you should watch my video on quadratic equation. Here we'll have to use the A, C, and B method. So we're gonna look for 2 numbers that if you multiply, it will give you 8, and if you add, it will give you minus 6. So that means it's minus 4 and minus 2. Minus 4 times minus 2 will give you plus 8. Minus 4 plus minus 2 will give you minus 6. So it's going to give you x minus 4 and x minus 2. Good. So factorize it, and I told you that then after factorizing it, so you have to then put it back. So it's going to be, we can then rewrite this again. Let me send the color for this. So this, we can write it again as 8x minus 28 divided by x minus 4, x minus 2. Now, these are prime factors. Now, if you look at the denominator is a linear factor. Remember, I told you linear factor is in the form of ax plus b, okay? So if you watch it, so that is the reason why for the first video, I'm going to talk about linear factor. The next video, I'm going to talk about ax plus b raised to power 2 factor. So that means this is a classical linear factor, okay? So then what is the next step to take then? So since we know this is a linear factor, and I told you that after you've done this in step 3, you need to break this down as each of the partial fractions as a component of the linear factors, right? So that means 8x minus 28 divided by x minus 4, x minus 2 will be equal to a, one of the constant over one of the linear factor, plus b over another of the what? Linear factor. So the next thing I told you was that you then have to multiply both sides by the denominator, okay? That was step 4, that you have to multiply both sides by the denominator. So what are you gonna do now? So we have, let me write it here. So we have 8x minus 28 over x minus 4, x minus 2, multiplied by the denominator. Let's put the denominator. So this number, we're going to multiply this by this number. It's equal to, same thing, you multiply each of them by the denominator. So it's going to be a, oh, sorry, let me do another color for that. It's going to be a, oh, y. It's going to be a. So we're going to multiply each of the components with a denominator. So multiply. Same thing, the same denominator. x minus 4, x minus 2. Okay. Then plus the same thing for the b. The b will do the same thing. It's going to be b over x minus 2 multiplied by the denominator, x minus 4, x minus 2. Okay. Then you cancel out. So x minus 4, this will cancel all this. So you're going to have 8x minus 28. This will cancel this. You're going to be left with ax minus 2 plus this will cancel this. And it's going to be bx minus 4. Okay. Now in stage 5, I gave you 2 methods to use. You can either use the substitution method or you can use the coefficient of terms method. All right. So here, like I told you, you have to use the substitution method first. Okay, it's easier. So what you just do, you look out for numbers that you can use that are going to cancel out. Okay, you're going to look for numbers that you can use that will cancel out. So here, I'm going to use both of the methods in this video. I'm going to use the coefficient methods, and I'm going to use the substitution method. But I'm going to start with the substitution method so that it will be to show you how easy the substitution method is and how long the coefficient of terms of the constant method will be. All right, let's go. So we're looking for a number that we're going to substitute that all the constant term, in this case, we only have 2, a and b. So that means all the constant term will disappear and just leave only 1. So if you look at this carefully, the only thing you can do is if I put x to be equal to 2, all this will go away, and I'm only going to be left with b. Can you see? So that means I can use x equal to 2. So I will say let's x to be equal to 2. So I'm going to put 2 here. It's going to be 8, 2 minus 28 is equal to a 2 minus 2, okay, plus b 2 minus what? 4. So 2 minus 2 will give me 0. So I will be left with b now. Can you see? So that means it's going to be 8 times 2, 16. 16 minus 28 will give you minus 12. Will be equal to b. This should be minus 2b. Does that make sense? Divide both sides by minus 2 to find the b. So therefore, b will be equal to what? 6. Okay. Now, we've done that. We'll go back to this equation again. All right, we'll go back to this equation again. So now, what can we, since we found out b, we're looking for a. So what number can we make b so that b can disappear? Yes, you're right. It's going to be 4. So the same thing, you will say, let x to be equal to 4. Because when you put 4, b is going to disappear and you're going to be left with only 1. So remember, the key is that you're going to substitute a number that all the constant term, be it a, b, c, d, or anything, will disappear, just leaving only 1. So because you have to work with only one unknown. So that's going to give you 8 into bracket 4 minus 28 is equal to a into bracket 4 minus 2 plus b 4 minus 4. Can you see? All this will become what? 0. Then 8 times 4 minus 28 will give you 4. Will be equal to 4 minus 2 will give you 2, 2a. So you divide both sides by 2, divide both sides by 2, and then that will give you a to be equal to what? 2. So we found out a, and we found out b. So now we can go back to the partial fraction to get our answer. So based on this now, we can now say, based on the partial fraction, we can now say the answer for this now is going to be, a is 2, it's going to be 2 over x minus 4, plus b is 6 over x minus 2. So this is the partial fraction for 8x minus 28 over x minus 4 and x minus what? 2. And this is the answer you're looking for. Okay, and that is it. Easy and straight to the point. Now, I'm going to show you. I'm going to solve this same example now. I'm going to use the coefficient of terms method. Okay, you'll see how long it's going to be, but we'll still get the same answer. Okay, so that's the reason why I always say start with substitution. Then when you get to a point that you can't move on again, or you can't find a term that everything's going to become 0, then you now do the coefficient of term method. All right, so I'm going to go to another page and solve this question in another page. Let me open a new page here. Yes, so we have that. All right, so we have the same question. So it's going to still follow the same step. The first step to check the degree, we've done that already in step 1. So basically, from step 1 to step 4 is exactly the same thing. Is that making sense? So you check the degree, you factorize the denominator. Then after factorizing the denominator, you write it as a linear factor. After writing as a linear factor, you multiply both sides by the denominator, so you get there. So you do step 1 to step 4 until you get to this point. So you get 8x minus 28, ax minus 2. So assuming you've done step 1 to step 4. Okay, we've done step 1 to step 4, and we've gotten to the 8x minus 28 equal to ax minus 2, 8x minus 2. Then we have plus b x minus 4. All right. Now, this is the step now that you either use substitution method or you do the coefficient of terms method. All right. So what you do then is that you have to make sure that all the brackets or everything are open up, so it will be easy for you to work with. Okay. So I can open up all the brackets now. So I'm going to solve this. So this is going to give me 8x minus 28. So basically, you have to make sure that all the x are together. So basically, I equal the coefficient of x and the coefficient of the constant. Okay. So I'm going to open this bracket. Now it's going to give me ax minus 2a plus bx minus 4b. Okay. And I collect the like terms. So it will be ax plus bx minus 2a minus 4b. So x is constant. Sorry, x is common in both of them. So I want to have a plus b all x minus 2a plus 4b. And this is equal to 8x minus what? 28. Okay. So what this method involves is that you're just trying to get the coefficients for each of them. So for instance, what is the coefficient of x on the left-hand side? You also look for the coefficient of x on the right-hand side. What is the coefficient of x squared on the left-hand side? You do the same thing, the same coefficient on the right-hand side. What is the constant term on the left-hand side? Do the same thing on the right-hand side. So let's start with x. Okay, so what is the coefficient of x here? 8. So we're going to start with the coefficient of x. Okay, coefficient of x. Now, what is the coefficient of x here? Is 8. What is the coefficient of x here? Is a plus b. And this is the first equation 1. Are you seeing it? The next thing, what is the constant term you have on the left-hand side and the constant term on the right-hand side? So the constant term on the left-hand side was minus 28. Okay, so this is minus 28. And the constant term here is going to be minus 2a plus 4b. So that means if you open the bracket, minus 28 is going to be minus 2a minus what? 4b. So we have equation 1 and we have what? Equation 2. So from equation 1, okay, so from equation 1, we can see that 8 is equal to a plus b. So therefore, I can say a is going to be 8 minus b, okay? So a is equal to a minus b. So this is what I'm going to substitute in equation 2. So let's call this equation 3. So I'm going to substitute equation 3 into equation 2. Okay, so this is my 2. So we have minus 28 is equal to minus 2a minus what? 4b. So it's going to be minus 28 is equal to minus 2 into brackets. The a is 8 minus b minus what? 4b. So you just substitute it there. Then, as usual, you open the bracket. So it's going to give you minus 28 is equal to minus 16 minus 2 times minus b will give you plus 2b, then minus 4b. Okay, you take 16 to the other side. So it will be minus 28 plus 16 is equal to 2b minus 4b. Minus 28 plus 16 will give you minus 12. 2b minus 4b will give you minus 2b. So you notice that it's exactly the same thing we got here when we're looking for b. Can you see? It's exactly the same thing we got here. So you see, with substitution method, it took us less than a step to get there. But with the quotient of terms method, we had to do a lot of manipulation to get there. But like I said, quotient of terms substitution method is faster, but it's limited. But the quotient of term, it's going to be a very long method, but it always give you the answer. So minus 2 divided by minus 2. So therefore, b will be equal to 6. Are you saying? B to be equal to 6. Now we're going to substitute b equals to 6 in equation 3 so that we can get our a. So therefore, a will be equal to 8 minus b. So that means give you 8 minus 6. So therefore, a is going to be what? 2. So that means we've gotten our a to be 2 and our b to be 6, similar to what we did here as well. Then you go back to the equation in the equation step 3 of the rule, and you put a to be 2 and b to be 6. All right. Okay, and this will bring me to the end for this video on partial fractions with linear factors. Okay. Now, moving forward, I'm going to only be solving with the substitution method in the other videos now, but I'll use both methods, both substitution and coefficient of time. So I'll start with substitution. And if I can move forward, then I'll go to coefficient of time. So please try as much as possible to play around with questions. And if you have any questions, just let me know, or you can send me an email and I'll respond to you. Okay. The next one I'm going to talk about now is that maybe I can take one more question. I might take one more question and see if I can do that, or I might go straight to partial fractions with linear factors. But I think what is the best thing to do is, let me take a question on when the degree of the numerator is higher than that of the denominator. So remember in the 5 rules, I told you that if the degree of the numerator is higher, you have to first do long division first. Then after long division, then you start partial fractions, okay? So I'm gonna do that first. I think I'm gonna do that first in the next video. Because in this video, the degree of the denominator was higher, so we went straight into partial fractions. But for the next video, I'm gonna do when the degree of the numerator is higher than that of the denominator, you start with long division and you move on to that. So I'm gonna see you in the next video. Please don't forget to ask any question, put it in the chat box, and I will get back to you. All right, thank you very much. Right.